The stone remembers what we don't. Number 10. The Carboniferous oxygen spike. Oxygen flooded the atmosphere to 35%, and the world burned so often that fire became the architect of life itself. 300 million years ago. The air changed, not slightly, not gradually. Oxygen rose to 35%, nearly double what we breathe now. The atmosphere became a fuel tank waiting for a spark, and the sparks came lightning, volcanic heat, a dry branch rubbing against another in wind. The forests burned, then they burned again. Then they burned so often that fire stopped being a disaster and became a condition of existence. Charcoal layers in the Carboniferous rock run thick and regular bands of black between the seams of coal dot proof that the ground was on fire more often than it was not, and the ground remembers. The world was a swamp. Giant club mosses rose 100 feet, their trunks straight and unbranched until the crown. Ferns grew as tall as trees. Seed ferns spread their fronds in the damp heat, and horsetails formed dense thickets along every waterway. The ground was waterlogged, the air was heavy, the silence between fires was the only quiet the world ever knew. Nothing decayed properly. The oxygen was too high. The microbes that break down dead wood had not yet evolved the chemistry for it, so the dead plants piled up, layer on layer, they compressed under their own weight. They became the coal beds we mine today. Every lump of coal is a ghost of a plant that never rotted in a world that never stopped burning. Picture it, insects with wingspans wider than a hawk's forearm. Dragonflies the size of eagles, tracing slow patterns above the swamps. Centipedes 6 feet long, moving through the root systems, their legs rippling like water. Arachnids the size of a human head, crouched in the shadows. The high oxygen did not just feed fire, it removed the ceiling on body size. Insects breathe through tubes in their bodies, and the more oxygen in the air, the larger those tubes can grow before diffusion fails. The Carboniferous air let them become monsters. But the crack is this: no one can fully explain why the oxygen climbed that high. Plants were pulling carbon from the air, yes, that much is clear, but the numbers do not balance. The carbon buried in coal does not account for the full spike. Something else was driving the atmosphere toward a state where the entire planet was one ember away from ignition. Some researchers point to a shift in the carbon cycle, a slowing of decomposition that let organic matter lock away carbon faster than volcanoes could return it. Others argue that the burial rate of organic material in coastal swamps was the engine, that the geography itself was the cause. A few suggest that the oxygen spike was not one event, but a series of pulses, each one pushing the atmosphere closer to its limit. None of these models close the gap entirely. None of them explain why it stopped. Then it ended. Because it did stop, the oxygen fell, the fire slowed, the giant insect shrank. The coal seems thin out and the charcoal bands fade. Something pulled the world back from the edge, or the edge simply collapsed on its own. The record does not say. There's only certainty, is that the world came closer to burning itself out than it ever had before, and closer than it ever has since. And whatever triggered the rise, whatever ended it, both remain unnamed. The air itself turned against the living, but air was not the only element that betrayed the world. Later, much later, the Earth would run a fever of a different kind, one that rose from below at number 9, the Paleocene-Eocene thermal maximum. The planet's temperature jumped 8 degrees, and the carbon that did it came from somewhere we still have not found. If you want to see where this goes, hit subscribe, the deepest one is still ahead. 56 million years ago, the Earth was already warm. Palm trees grew in what is now Wyoming. Crocodiles floated in the rivers of Greenland. The Arctic was temperate, its waters mild enough for floating ferns, its coastlines free of ice for the entire year. Then the warmth accelerated. In the geological equivalent of a single breath, 5,000 years. Perhaps less global temperatures surged another 8 degrees. The ocean surface at the equator reached nearly 100 degrees Fahrenheit. The deep oceans warmed enough to change their chemistry entirely. Something had flooded the atmosphere with carbon. A massive pulse of carbon dioxide or methane or both. The fingerprints are there in the isotopes, locked in the shells of tiny organisms that died and sank to the seafloor. The carbon signature is unmistakable. It is light. It carries the mark of organic material, not volcanic gas. Something organic, something vast, opened and released its contents into the sky. The sky absorbed it, but the source has never been found. Some say it was methane hydrates, frozen deposits on the ocean floor that thawed as the water warmed, releasing their load in a cascade. The problem is that something had to warm the water first to trigger the thaw, which means the methane was an amplifier, not the cause. Others point to a vast volcanic province in the North Atlantic where magma moved through carbon-rich sediment and cooked the carbon out of the rock. The timing is close, but not exact. A few researchers argue for a comet impact, a carbon-rich body striking the Earth and vaporizing. No crater has been found. No impact debris matches the date. The carbon came from somewhere. The isotopes say so, but the somewhere remains unnamed, and the consequences do not. The acidification of the oceans was severe enough to dissolve the shells of creatures that had built them for millions of years. Corals suffered. Foraminifera, the tiny architects of the seafloor, nearly vanished from the record. On land, mammals shrank, their body sizes dropping by a third in the warmest stretch, as if the heat itself was compressing them. The deep ocean lost its oxygen, entire ecosystems reorganized, some vanishing entirely, others appearing for the first time. The world did not die, but it was rewritten. The migration patterns shifted. Species that had never shared the same latitude suddenly found themselves neighbors. The tropics became a furnace, too hot for many organisms to survive. The poles became a refuge. Life moved poleward or it perished. Then over 100,000 years the planet pulled it back. The carbon was absorbed, the oceans drew it in. The temperature fell, the shells returned, the mammals grew again. The planet stabilized as if nothing had happened, except something had. The carbon spike left a signature in stone that scientists still study today. Not because it is ancient history, but because it is a mirror, a carbon pulse, a temperature spike, an ocean acidifying, the same sequence, the same chemistry. The only difference is speed. We are doing in 200 years what took 5, 0 then. And the source of the original pulse, the one that started it all, is still down there somewhere, locked in rock, waiting to be found. The heat rose from below, the planet answered. But heat was not the only way the world turned hostile. Long before this fever there was a drowning. A storm that did not end for 1,000,000 years, number 8, the Carnian pluvial episode. It rained for nearly 2 million years straight. And whatever crawled out of the drowning world became the rulers of everything that followed. 234 million years ago, the world was dry. The supercontinent Pangaea sat under a brutal sun. Deserts spread from pole to pole. The interior of the landmass saw almost no rain at all. Then the rain came, not a season of it, not a decade. Nearly 2 million years of it across every latitude, on every coast, in every basin that could hold water. The evidence is in the rock. In the Dolomites of northern Italy, geologists found a sudden shift. Carbonate platforms that had been building in clear, dry conditions replaced by thick beds of siliciclastic sediment, the signature of relentless runoff. The same pattern appears in the Alps and the Himalayas and the deep-sea cores of the Pacific. Rivers swelled, deltas expanded, the dry basins filled. The world went from arid to waterlogged. And it stayed that way for longer than the entire span of human civilization, multiplied by thousands. Then 4 million years later, the drought returned. The rivers shrank, the deltas hardened into stone, the lakes evaporated, leaving salt behind. The world dried out as suddenly as it had drowned, and the transition was sharp enough to leave a clean break in the rock, a line where the wet sediment stops and the dry sediment begins. Dies if someone turned a tap off. What caused the rain is debated. The leading theory points to the Rangelia Large igneous province. A volcanic eruption on the scale of a continent pumping carbon dioxide and moisture into the atmosphere for hundreds of thousands of years. The eruption warmed the planet, intensified the hydrological cycle, and turned the skis into a permanent faucet. Other researchers point to a shift in ocean circulation. As the Tethys Sea opened and reconfigured the flow of heat around the globe, some combined both. volcanism triggering warming, warming triggering circulation change delivering rain. But the real weight of the Carnian pluvial episode is not the rain itself, it is what came after. The extinction was moderate, not a mass dying, not a near miss. But the reshuffling was massive. Old species of crinoids and ammonoids vanished, new ones appeared, and on land, something shifted that would shape every animal that has lived since: the dinosaurs. Before the Carnian pluvial episode, dinosaurs were a minor group. Small, rare, unremarkable, barely a footnote in the fossil record. They had been around for millions of years, but they had not conquered anything. After the rain, they diversified, they spread. New species appeared in rapid bursts: the first large herbivores, the first apex predators, the first bipeds built for speed. Within a few million years, they were the dominant land vertebrates on the planet, and they would remain so for 160 million years. The rain did not just drown the old world, it built the foundation for this next one. The question is whether the rain was the trigger, or whether something deeper, something in the chemistry of the atmosphere and the ocean, set both the rain and the rise of the dinosaurs in motion. The rock records the wet years. It does not record the mechanism. The rain falls, the world changes, and the creatures that inherit it call it destiny. But the cause remains unknown. Water from above, but the worst water came from below. Deeper down in older stone, the oceans themselves turned to poison, and the death they left is still in the ground. Number 7. The Torsian anoxic event. The oceans died from the bottom up, and the black layer of death they left behind is still visible in the stone of 3 continents. 183 million years ago, the seafloor began to suffocate. The process was not fast by human measure. It unfolded over hundreds of thousands of years, but in geological terms, it was sudden. The deep waters lost their oxygen, then the midwaters, then the shallows followed. The oceans turned toxic layer by layer from the bottom to the surface, and the life inside them had nowhere to go. The evidence is unmistakable. A band of black shale, dark, dense, rich in organic carbon, runs through the rock of Europe, North America, and South America. In Yorkshire, the shale is exposed in cliff faces along the coast, a day-black stripe against the grey limestone that bookends it. In Germany, it appears in quarries, where miners have known it for centuries as a marker of dead ground. In Argentina, it cuts through the Andean foothills, the same black line, the same age, the same signature of a sea that could not breathe. The shale is the seafloor's death mask. When oxygen vanishes from the water, organic matter does not decompose. It sinks, it accumulates, it compresses into black mud, which compresses into black stone. The thicker the shale, the longer the dying. The Torsian shale is thick. The organic carbon inside it is measured in percentages that dwarf normal marine sediment. In places, the shale is more than 10% organic matter by weight. A concentration that requires not just death, but death without decay. The kind of death when the water above has nothing left to give. What caused the anoxia is contested. The Kara-Ferrar Large Igneous Province, a volcanic system spanning what is now southern Africa and Antarctica, was erupting at the time, releasing vast quantities of carbon dioxide and methane. The greenhouse effect intensified. The oceans warmed. Warm water holds less oxygen than cold water, and the ocean circulation slowed as the temperature gap between the poles and the equator shrank. The water stratified, the deep current stopped, the seafloor starved. Some researchers add a second trigger: a release of methane from frozen hydrates on the continental shelves, a cascade that made the warming self-reinforcing. Others point to an increase in nutrient runoff from the land. Wedge fed massive blooms of plankton that consumed the remaining oxygen as they died and decayed. Each theory fits some of the evidence, none fits all of it. The death toll was severe. Up to a quarter of all marine genera vanished. Ammonites, bivalves, brachiopods, entire branches of the ocean's family tree were pruned. The reef systems collapsed. The ecosystems that survived were simplified, stripped to the hardy and the small. Fish survived, but their diversity plummeted. The predators that relied on the lost prey starved in turn. Recovery took millions of years, and the ocean that returned was not the ocean that had died, and the black layer is still there. You can walk to it, you can put your hand on it. A seam of stone that was once the floor of a dead ocean, holding the carbon of every creature that sank into the silence. It is the closest thing the Earth has to a murder weapon, and the culprit is still at large. The question is not whether it could happen again. The question is what would stop it, and this one, strange as it is not yet the strangest, not even close, because what came next was not a catastrophe of scale. It was a catastrophe of smallness. Something tiny nearly ended the world. Number 6. The Azolla event. A fern no bigger than your fingernail covered the Arctic Ocean, dragged the planet's carbon into the deep, and nearly froze the entire world solid. 49 million years ago, the Arctic Ocean was a lake. It was landlocked, cut off from the global currents by land, bridges, and shallow sills. The water was fresh on top, salty below, and warm enough that the surface temperature reached 68 degrees Fahrenheit in summer. A tropical sea at the top of the world, sitting under a sun that never set for months at a time. Into that warm, still water, a fern arrived. Azolla, a floating plant no bigger than a fingernail, with overlapping leaves that trap air and keep it buoyant. It reproduces by doubling each frond, splitting into 2, then 4, then 8. And under the right conditions it can cover a lake in weeks. In the Arctic Ocean it found the perfect conditions. Still water, long light, no winter to kill it. It spread, it covered the surface, then it died, sank, and took carbon with it. Then it grew again. For 800,000 years the cycle ran. Azolla bloomed across the Arctic surface, pulling carbon dioxide from the atmosphere as it grew. Then it sank. Millions of tons of organic matter descending into the dark water, carrying the carbon with it. The ocean floor became a carbon vault. The atmosphere was steadily drained. The impact was planetary. Atmospheric carbon dioxide dropped from over 1,000 parts per million to below 400. The greenhouse effect weakened. The planet cooled. Antarctica, which had been warm and forested for tens of millions of years, began to ice over. The first glaciers formed on its mountains, then spread to its coasts, then covered the continent. The world that had been tropical from pole to pole since the age of the dinosaurs finally cooled down. But the question that remains is how it stopped. Years of relentless carbon burial, and then the Azolla vanished from the Arctic record. The ocean reconnected to the global currents, perhaps through a shifting coastline or a deepening strait. The fresh surface layer was swallowed by saltwater. The conditions that allowed the fern to bloom disappeared, and it never returned in force. One moment the Arctic was a factory pulling carbon from the sky. The next it was just ocean again. Some researchers argue that the Azolla event triggered the cooling that led to our Ice Age cycle, that without this fern Antarctica would still be green. Others caution that the carbon drawdown was part of a larger shift, that the fern was an amplifier, not a cause. The debate is active. The sediment cores are few, and the ocean floor has not surrendered its full story. The fern's remains are still down there. Drill into the Arctic seabed, and you find them layers of organic matter compacted in dark. The compressed bodies of billions of tiny plants that pulled the world toward cold. The layers run dozens of meters thick in places, a geological ledger of every bloom and every sinking death. They nearly froze everything. And they did it without fire, without impact, without eruption. Just growth, just sinking, just time. The cold came within reach of killing everything. But cold was not the only weapon the planet used. There is an extinction that killed more sea life than the asteroid that ended the dinosaurs, and its name is almost never spoken. Number 5. The Hangenberg Crisis. It wiped out more marine species than the asteroid that killed the dinosaurs, and almost no one has ever heard its name. 359 million years ago, the world was a place of abundance. Shallow seas covered the continents. Fish dominated the water-armored placoderms with bone-plate jaws, early sharks with jagged teeth, lobe-finned fishes building the body plan that would one day become our own. The reefs were dense, the food chains were long. Life had been building complexity for over 100 million years, and the ocean was its showcase. Then the water changed. The Schöningen crisis did not arrive with a single blow, it unfolded in stages. A regression of the sea level, a collapse of oxygen, a die-off that rolled through the oceans like a slow wave. The shallow seas drained as the water receded. The reefs that had thrived in the warm shallows were left exposed. The creatures that could not follow the retreating water perished where they stood. It hit hardest at the top. The apex predators, the giant placoderms, armored titans that had ruled the Devonian seas, vanished entirely. Not some of them, all of them, an entire order of fish gone. The sharks survived, but their diversity was cut in half. The lobe-finned fishes, once the most varied group in the ocean, were reduced to a handful of lineages. The ammonites took heavy losses. The trilobites, already diminished from earlier crises, lost more ground. The reef builders did not just die. The entire architecture of reef ecosystems collapsed, and it would take millions of years for reefs to return in any recognizable form. On land, the impact was quieter but real. The early forests that had begun to colonize the interior of the continent shrank. The seed ferns and early conifers pulled back to the waterways. Soils that had been stabilized by roots eroded into the rivers, carrying sediment and carbon into the sea. A feedback loop that may have worsened the anoxia below. The cause is unresolved. Some researchers point to a rapid climate shift, any sudden cooling that collapsed tropical habitats and forced organisms into refuges. Others argue for intense volcanism driven by the continental collisions building Pangaea. The volcanic gases would have altered the atmosphere and disrupted the carbon cycle. A third theory invokes a massive asteroid impact. Though no crater of the right age has been convincingly identified, each hypothesis fits part of the evidence. None explains the full scope of the dying. What is strangest is the selectivity. The crisis did not erase life uniformly. It targeted the large, it targeted the specialized, it targeted the apex, the creatures that had dominated their ecosystems for tens of millions of years, and it left the small, the generalist, the unremarkable, as if the planet was not just killing, but choosing what to kill. The Schöningen crisis closed the Devonian period. It opened the door to the Carboniferous, a world rebuilt by the survivors, not the rulers. The seas filled with new fish, new sharks, new ecosystems, but the armored giants never returned. Their bones sit in the rock, perfectly preserved, evidence of a world that worked until it didn't. Everything so far has been the shallow water. From here on, the floor drops out, the oceans went dark. But the way they went dark, that is what haunts. In an older layer of stone, the dying did not come all at once. It came in waves as if something was deciding how much life could take. Number 4. The Lao event. The extinction came in pulses, as if something was testing how much life could survive before it finally broke. 427 million years ago, the world was still recovering from the first great mass extinction, the Ordovician Silurian crisis that had wiped out nearly half of all marine life. The seas were repopulating. The corals were building new reefs. The brachiopods, shell-bearing creatures that clung to the sea floor like living hinges, had diversified into hundreds of species. Life was climbing back. Again, the Lao event did not strike once. It struck in pulses too, possibly 3 distinct waves of extinction, separated by a brief recovery, each hitting harder than the last. The first pulse took the shallow water species. The second reached deeper. The third touched the open ocean. Between each wave, the surviving species rebounded slightly, as if the world was catching its breath before the next blow. Gotland, Sweden preserves the evidence in limestone, a small island in the Baltic Sea where the Silurian seafloor has been lifted to the surface, tells the story in layers. Healthy reef limestone, then a thin band of dark, organic rich sediment, the signature of anoxia, then a return to lighter carbonate, then another dark band, then another. Each dark layer is a death. Each lighter layer is a partial recovery. The pattern repeats, and each time the recovery is weaker. Carbon isotopes in the rock shift wildly during the Lao event, a signal that the global carbon cycle was destabilizing. The shifts are abrupt, far faster than the background noise of the era, and they coincide exactly with the extinction pulses. Something was injecting carbon into the ocean atmosphere system in bursts, and each burst was enough to knock the chemistry of the planet off its foundation. What caused the pulses is unclear. The most widely discussed mechanism is a series of sea level fluctuations, the water rising and falling, each cycle exposing the shallow habitats to air and then drowning them again, each swing killing the communities that had just begun to recover. But the scale of the carbon isotope shifts suggests something more than water level. Some researchers argue for repeated volcanic injections of carbon dioxide, perhaps from a large igneous province whose remnants have not yet been identified. Others point to episodes of methane release triggered by the warming that followed each volcanic pulse. The methane would have amplified the heat, deepened the anoxia, and driven the extinction further, then dissipated, allowing a brief recovery before the next injection. A single catastrophe can be explained: an asteroid, a volcano, a shift in the ocean, a catastrophe that strikes, retreats, and strikes again, each time hitting harder, suggests something else entirely, and a system oscillating toward collapse. A world being tested to destruction, and a record left behind in case anyone ever cared to look. The limestone on Gotland still holds the evidence. You can walk along the coast and run your hand across the dark bands, each one a moment when the sea lost its oxygen and the creatures inside it lost their hold on the world. The rock does not explain itself. It simply records. And still, the deepest cuts are ahead, because the next erasure did not target the weak. It targeted the most successful creatures the planet had ever built. And we still do not know why. Number 3. The Eiaweischen event. It erased 80% of the most successful animals the planet had ever produced, and the cause is still a blank. 434 million years ago, the graptolites ruled the water column. They were small, most no longer than a finger colonial animals that built tiny housing tubes from protein and lived in floating chains that drifted through the open ocean. They had been among the most abundant organisms on Earth for over 100 million years. Their fossils are so common that geologists use them to date the layers, a different species for every few meters of stone. Then the Eiaweischen event hit. 80% of graptolite species disappeared, not over millions of years, over tens of thousands, a geological instant. The floating chains that had filled every ocean simply broke apart, and most of them never reassembled. The extinction was not limited to negraptolites. Conodonts, tiny eel-like animals with complex tooth-like elements in their throats, lost more than half their species. Trilobites took heavy losses again, their diversity shaved down further. The reef communities in the shallow seas were disrupted, their species composition shifting as old forms vanished and new ones took their place. Physically, the evidence is thin. No dramatic black shale, no massive ash layer, no clear geochemical fingerprint that points to a single cause. The carbon isotope record shows a positive excursion, a shift that suggests organic carbon was being buried rapidly, pulling carbon out of the system. But the shift is modest and its meaning is debated. What is clear is that the event coincided with a major sea level change. The oceans rose, flooding the continental shelves, then fell again, draining the shallow habitats. Each shift would have stressed the communities that lived in the margin between land and sea. But a sea level change alone does not explain an 80% extinction rate among open ocean organisms like graptolites, which were not tied to the seafloor at all. They floated. They should have been insulated from the rise and fall of the shelves. That is the crack. Something reached them. Something in the chemistry of the water, the temperature of the surface, the oxygen content of the deep. Something that could touch the open ocean as easily as the coast. And whatever it was, it acted with a precision that targeted the most successful animals alive. Theories have been proposed. One invokes a shift in ocean circulation that brought anoxic water to the surface, suffocating the colonies. Another suggests volcanic activity triggered rapid climate change, a warming spike followed by a cooling snap, each phase killing different species. A third points to a change in marine productivity that collapsed the food web from the bottom up. None has gained consensus. The evidence is too fragmentary, the event is too old. The rock that recorded it has been compressed, heated and eroded over nearly 500 million years, and much of what it once held is gone. What remains is the number. 80% of the most successful animals the planet had ever produced erased. The graptolites that survived went on to live for tens of millions of years more, but they never regained their former diversity. The world they had dominated was gone, and something else moved into the space they left behind. The strongest did not survive, and that truth runs deeper than this one extinction. Because next came a moment when the planet simply changed its mind, and everything that could not adapt was just gone. Number 2. The Eocene-Oligocene transition. The planet had been warm for 40 million years. Then, in a geological breath, Antarctica froze over, and everything that could not handle the cold simply ceased. 34 million years ago, the world was still holding on to the warmth. The Eocene epoch had been a long summer crocodiles in the Arctic palm trees in the Rockies, deep oceans that never dropped below 50 degrees. For tens of millions of years, the planet had been a greenhouse. Then the temperature dropped, not slowly. The shift took 300,000 years, a geological breath, and when it ended, Antarctica was buried under ice. The evidence is locked in the sediment of the Southern Ocean. Drill cores from the Antarctic shelf show a sudden change. The carbonate shells of marine organisms give way to glacial debris. Ice had reached the sea. The transition is sharp enough to see with the naked eye a change in color, a change in texture, in a line where warmth ends and ice begins. On land, the effects cascaded. The forests that had covered the northern hemisphere contracted. Broadleaf evergreens retreated to the equator, replaced by deciduous trees and dry adapted shrubs. The mammals that had lived in those forests, small, fruit-eating, warmth-dependent, found their world shrinking. Many did not survive. The earliest primates, once widespread across North America and Europe, vanished from the northern continents almost entirely, surviving only in the tropics. What caused the freeze is debated. The leading theory points to the opening of the Drake Passage, the gap between South America and Antarctica. When the continents separated, the Antarctic Circumpolar Current formed, isolating Antarctica from warm tropical water. The continent cooled, ice accumulated. The albedo effect accelerated the cooling. The feedback fed itself until the continent was locked in white. But the timing does not quite align. Some records suggest the passage opened millions of years before the freeze, others placid after. The match is not clean. Additional factors have been proposed. A decline in atmospheric carbon dioxide, a shift in the Earth's orbit, changes in weathering rates that drew down greenhouse gases. Each contributes a piece. None completes the puzzle alone. The extinction was not a single wave. It was a draining. Species did not die in a catastrophe. They faded as their habitats contracted, as the warm zones they depended on shrank toward the equator. The ocean floor changed, the forests changed, the animals changed, and the world that emerged was colder, drier, more seasonal. The world we inherited. Antarctica's ice has never fully retreated. It has been there for 34 million years, holding enough water to raise the sea level by nearly 200 feet if it melted. The transition that put it there was not a cataclysm, it was a correction. The planet shifted from one state to another, and the life that could not shift with it was simply left behind. A whole world reordered by silence and ice. But even that is not the deepest cut. The deepest one is quieter, no fire, no flood, no freeze, just a break. A line in the fossil record where everything on one side simply stops and something else begins. Number 1. The Grand Coupure. They call it the Great Break, the moment entire animal lineages vanished and were replaced by strangers, and no catastrophe has been found to explain it. 3.3 million years ago, just after the Eocene-Oligocene transition had turned Antarctica to ice, the mammals of Europe changed, not gradually, not through the slow replacement of one species by another, over millions of years. They changed in a break, a line drawn across the fossil record. Below the line, one fauna above it, another, and almost nothing crosses. The term was coined in 1901 by the Swiss paleontologist Hans-Jörg Stalin. Grand Coupure, the Great Break. He noticed something that should not have been there. The animals that dominated the late Eocene, the Paleothers, distant relatives of the horse, the Anaplothers, slender creatures with cloven hooves, the adapted primates, small and lemur-like, all of them vanished, not some, nearly all. In their place above the break, new animals appeared. Rhinoceroses, deer-like ruminants, new rodents. The fauna of Asia had arrived. Because that is what the evidence suggests. The new species bear a strong resemblance to the mammals of Asia. The most widely accepted explanation is that a land bridge formed between Europe and Asia as sea levels dropped, allowing Asian mammals to migrate westward. The newcomers outcompeted the residents and the old European fauna collapsed. But the problem is the speed. The break is sharp. In some sites, the old fauna and the new fauna do not overlap at all. The old one is there and then it is not, and the new one has already taken its place. If competition drove the replacement, it happened faster than competition usually works. Faster than the fossil record typically shows for a gradual turnover, silence. And there is a deeper problem. The Grand Cooper does not coincide with any known catastrophe, no impact crater, no massive volcanic province erupting at the right time, no sudden anoxics event, no black shale, no ash layer. The Eoceno-Lagos scene transition was happening. The world was cooling, the ice was growing, the forests were contracting. But the transition was gradual enough that the mammals should have had time to adapt. Many did not. The break is too sharp for the cause to be climate alone. Some researchers argue that the cooling was more abrupt in Europe, that the continent at higher latitudes felt the chill sooner. Others suggest the sea level drop destroyed the coastal habitats where many old species lived. A third group points to the spread of grasslands, a new ecosystem favoring the grazing adaptations of Asian newcomers over the fruit-eating specialists of the old European forests. Each theory explains part of the evidence. None explains the sharpness of the line. The Grand Coupure was not a mass extinction. The total species loss was modest, but it was something else. It was an erasure of identity. The mammals that had defined Europe for millions of years were replaced by strangers from the east. The old families did not just die. They were written over as if the planet had decided their chapter was finished and a new one had already begun. In the Cus quarries outside Paris, in the sandstones of southern England, in the river deposits of Switzerland, the break is still visible. Below it, Paleothers and Anaplothers. Above it, rhinos and ruminants, a clean cut. No warning, no survivors. And the cause sits in the rock unnamed, a break without a blade, a replacement without a war. The deepest mystery in this countdown is not the loudest or the most violent or the most vast. It is the quietest, a line, a change, a world that simply stopped being what it was, became something else for reasons that are still unknown. 2 billion years ago, a single organism began producing a gas so toxic it poisoned the entire planet, and that gas was oxygen. The first mass extinction was not caused by an asteroid or a volcano. It was caused by life itself, and the evidence is still buried in the stone beneath your feet.